the Vedantu team, it's not just the in-depth subject matters that were taught to us, but also the exam-specific strategies we were asked to use.
Hi guys, how are you? क्या हाल चाल है? Hello Abhishek, hello Ajay, hello Anit. I'm Sourav and this session is again on Nernst Equation. The last session was conducted on Nernst Equation. We had done some problems and this session is again on that lines. But इस session में हम करेंगे क्या कि we will take questions which have come earlier in JEE Advanced as well as JEE Mains and we'll try to work through them. Okay. So my name is Sourav and you are on the Vedantu channel and we are doing electrochemistry right now. We have already completed some lectures. Please sit with a pen and a paper and try to solve as many questions as possible in the minimum amount of time with maximum accuracy. Okay, so hello Sugandh, hello hello Ajay, hello Anamika, hello Abhishek. So it's nice to see you guys turn out such a number, and a very important information to everybody that the VSAT Vedantu scholarship admission test is going to be held on Thursday 1st of August and Sunday 4th of August at these designated times. Thursday को ये 7 बजे होगा और Sunday it will be held at 3 o'clock. So please do register for the test and you can get handsome scholarships for paid courses. Please do let your friends know. This is from grade 6th all the way to for droppers as well. 13th represents droppers, so 6, 7, 8, 9, 10, 11, 12. So so there are 2 times. So अगर आप Thursday को miss करते हैं तो Sunday को दे सकते हो, और if you are like busy on Sunday you can give it on Thursday. So please do let everybody know that VSAT is going to be held on these 2 dates, Thursday 1st of August and Sunday 4th of August. Also, please do like, share and subscribe the channel so that you are always updated with the awesome content that keeps coming on a daily basis. And with that note, let's start today's session. आज के session का objective है कि हमने problems complete कर देना है. In the next session, we would be discussing concentration cells, which is a very interesting aspect. And while discussing concentration cells, we'll try to understand that what was the need of salt bridge. But for now, हम लोग problems last class में कुछ half problems किए थे. Today we will do some more problems. And can a person complete JEE Mains topic in 6 months? If you invest those 6 months properly, you can. Okay. So problems we are doing problems on Nernst equation. Today we would be taking problems which have come earlier in JEE Mains as well as JEE Advanced. Okay. So let's see how many problems we can cover in today's class. And let's start off with the first problem, which is right on the board. So the first question is, if the standard electrode potential for a cell is 2 volts at 300 Kelvin, the equilibrium constant K at 300 Kelvin is approximately equal to. Okay, this question came in JEE Mains January sitting on 9th of January. Question देखिए and try to solve. I'm giving you a minute's time to solve the question. And इस question को solve अगर आप कर लेते हैं, then it's like you are almost on the right lines in understanding what is the relationship between the equilibrium constant and cell potential. Okay, so आप solve करने की कोशिश कीजिए and then I will help you out to answer this question. जिनको नहीं आता है, not a problem. Thank you, smart boy. Okay, so the question is, the standard electrode potential for the cell is 2 volts at 300 Kelvin. The equilibrium constant is to be calculated. Okay, so let's try to see how to work out through this problem. It's not a very difficult one, it's an easy one. देखिए बात की गई है standard electrode potential की. So that represents E naught. It represents E naught. If the standard electrode potential is 2 volts and we are talking about equilibrium constant, so you know this expression, E is equal to E naught minus RT by NF ln q. You know this equation, okay? E equals to E naught minus RT by NF ln q. What happens when we take equilibrium? At equilibrium, q turns out to, at equilibrium q को हम k के बराबर लिख देते हैं. Okay, we write q as equal to k and E becomes equal to 0. Okay, delta G is equal to 0, delta G naught is not equal to 0, so E is equal to 0, E cell is equal to 0, E cell is equal to 0. Okay, now how do we write this? So if E is equal to 0, I will write it as E naught, which is equal to RT by NF ln K. Cool? RT by NF K. Now it is given that this is the reaction. Can you tell me how many electrons are being utilized? This N represents the number of electrons. So Anamika, Ranjana, all of you have given their answer. Let's see. So zinc changes to zinc 2 plus, 2 electrons are lost, and Cu2 plus changes to Cu, it takes up 2 electron. So I can write the value of N as equal to 2. So N की value हम 2 लिखेंगे. What is the value of F that I have to take? 96,000. And R value is 8. According to the question, 8, R is equal to 8.314. But according to the question, I have to take it as equal to 8. क्योंकि देख लीजिए यहाँ पे लिखा गया है R is 8 and F is this. And T is 300 ln K and E naught is equal to 2. Okay, so 8, if I try to solve this, so this becomes 4, 4, 3, 12, 12, 8, and this goes out. So 80 times 2 is, so ln K is equal to 160, or K is equal to E to the power 160. The right answer should be A. The right answer should be A. It's E to the power minus 160 लिखा गया है. Okay, so think carefully. Answer should be A. It's not C. Answer should be A. It's not C. E to the power minus 160 is written. Answer should be E to the power 160. Silly mistake, but you will lose 4 marks. Okay, बहुत simple सा question है. If you make such mistakes, you will lose marks. Okay, तो आपने question पूरा solve किया, लेकिन आपने मार्क करने में गलती कर दी. आपने देखा नहीं यहाँ पे माइनस है, यहाँ पे प्लस है. So please do keep these things in mind. देखिए JEE मेंस का question है, so it's not gonna be you have to put your attention to it. So question may be looking easy, but they will always put it up with some kind of a trap. Okay, itna yeah, it's such a silly mistake, so don't worry, but please be a little attentive. Cool? Chalo, let's go on to the next question. Next question is this. Next question is this. In a cell PT solid H2 HCl AgCl AgPt, the cell potential is 0.92 when 10 raised to 6 molal HCl solution is used. The standard electrode potential of AgCl AgCl minus electrode is. Now this problem is slightly complicated, but I'm still giving you some time. आप कोशिश कीजिए solve करने का. This question came in January mains, like in the January setting of JEE Mains 2019. So कोशिश कीजिए solve करने का, क्या का आंसर आता है. Please let me know and we can like proceed ahead from here. बताइए क्या होना चाहिए इसका आंसर. This question is not difficult, however, the question is slightly tricky. So not very difficult, slightly tricky. How do you utilize these informations is important. B is not the answer. Hemant, think carefully. B, I don't think B should be the answer, but I don't know. Let's see. Hemant is saying B. Anybody else with an answer? Okay. Anit, Ratnadeep, Anamika, Shushant. Let's see कैसे solve करना इस question को. So question is this. This is the cell. This is the cell. Now can you tell me what is the oxidation half cell? The oxidation half cell is this one. This one is the oxidation half cell. And this one is the reduction half cell. Okay, how do I write the reaction? पहले हम reaction लिखने की कोशिश करते हैं. So I will write it like this. H2 changes to H plus. I can write half H2 over here, and this gives out 1 electron. This gives out 1 electron. And for the other side, I'll put half, just because हमको balance करना है. Okay, the oxidation half cell reaction is balanced like this. I will try to write the reduction half cell reaction. Reduction half cell mein I have taken AgCl. Now AgCl is a solid, sparingly soluble salt. It will take up an electron and form Ag solid. This is also solid. This is solid. This is gas. This is aqueous plus Cl minus aqueous. This is the reaction that would be written. This is the reaction that would be written. Now when I write this reaction and I balance this reaction, the reaction looks balanced. 1 electron is given out, 1 electron is taken in, and if I write the overall reaction will look something like this. Half H2 gaseous plus AgCl solid, that changes to H plus aqueous plus Ag solid plus Cl minus aqueous. Okay, this is the whole reaction that would be written for this electrochemical change. Okay, इस electrochemical cell में जो reaction हो रहा है, this will be the whole reaction. Now if I write this reactions, I have to calculate a standard. So if I write the expression for Q, I will write it as, tell me something, would I include solid in writing the expression for Q? Should I include solid? Solid को include करते हैं या नहीं करते हैं? Should I include solid? No, I should not be including solid, for the reason that solid's activity is considered as to be 1. I will include the aqueous things and the gaseous part. So I will write it as H plus Cl minus upon H2 to the power 1 by 2. Okay, our expression for Q will be like that. Okay, our expression for Q will be like that. Everybody who has said no, we cannot include the solid is right, because solid's activity is taken as 1. So our expression for Q will be equal to this: H plus concentration, Cl minus concentration divided by hydrogen's pressure taken at this particular temperature. Now with that thing in mind, let us move ahead. Okay, so I will write E cell as equal to E naught cell minus 2.303 RT by NF log Q. Okay, I will write the Nernst equation like this. Now अभी मुझे निकालना है standard. I need to calculate standard. So I can obviously assume that the reaction is taking place at equilibrium. मैं ये मान लेता हूँ कि reaction equilibrium पे हो रहा है, क्योंकि ये AgCl solid sparingly soluble salt के बारे में जो भी concentrations हम measure कर रहे हैं, we are measuring when it is a saturated solution, and saturated solution means equilibrium condition. So E cell will become equal to 0, and E naught cell is given as E cell is given as 0.92. E naught cell can be written as E naught for oxidation plus E naught for reduction. I'm sorry, since it is given for E cell, it's given for E cell, तो reaction equilibrium पे हम नहीं ले रहे हैं. So I'm just gonna write E cell is 0.92, E naught oxidation, E naught reduction. This would be written as 0.06 upon the number of electrons which were exchanged was 1. This is log of H plus ion concentration times, okay, this is H plus ion concentration times OH minus ion concentration. So अब देखो यहाँ पे HCl कितना लिया गया है, 10 raised to minus 6 molal, 10 raised to minus 6 molal. So you can see that the E cell value is given as 0.92. Ignore my previous articulation. E cell is given as 0.92. मैं 0.92 value यहाँ पे रख दे रहा हूँ. E naught cell is given as E naught oxidation, E naught reduction. This 2.303 RT by F is given as 0.06. Number of electrons which were exchanged was 1. Log HCl solution का concentration 10 raised to minus 6 molar है. इसका मतलब H plus ion concentration is 10 raised to minus 6 and OHCl minus ion concentration is 10 raised to minus 6. Pressure of hydrogen is 1 bar. Okay, it's given 1 bar. तो by 1 कर देते हैं यहाँ पे. Now the E naught oxidation, this part represents standard hydrogen electrode for this E naught oxidation is equal to 0. Okay, E naught oxidation is equal to 0. So this will just be E naught reduction 0.92 minus 0.06 upon 1 and 10 raised to minus 12. So this will be minus 12. Okay, so 12,672 and 0.72 ये हो जाएगा. This will be plus 0.72 will be equal to E naught reduction 0.92. E naught reduction value will become equal to 0.20. Okay, the right answer should be A. The right answer should be A. Yeah, you can ask a question, not a problem. I hope this is understood to everybody. This is a very simple question. However, you just need to know that for Q, H plus ion concentration, OH minus ion concentration is given as what we have been given over here. So I have been taking, I've been given HCl concentration 10 raised to minus 6 molar. So H plus ion concentration will also equal to 10 raised to minus 6 and HCl minus concentration will also be equal to 10 raised to minus 6. अरे यहाँ पे दिया गया है देखो, this is given as this 0.06 is given. Okay, it's already given over here. चलिए, let's move on to the next question. This is a very simple question. Mains में आया था लेकिन simple question है. डर लगता है सवाल देख के यार, डरने से तो काम नहीं चलेगा. ठीक है, सो सारे बच्चों को डर लगने लग गया तो क्या करोगे? ठीक है. Now, next question. Given that the equilibrium constant Kc for the reaction is 10 into 10 raised to minus 15, you have to identify the E naught of this cell reaction. Okay, you have to calculate the E naught of the cell reaction. I'm giving you a minute's time to solve. बहुत सिंपल सा क्वेश्चन है, E naught निकालना है. कैसे आप निकालोगे? आपको मालूम है, you have to use Nernst equation because they are using Kc, equilibrium constant is being used. Use Nernst equation, try to solve the question. What is the answer? Even if that is 10 raised to 15, 10 times 10 raised to 15, Vikalp Tripathi, that is 10 times 10 raised to 15. The question is quite easy. Okay, the question is quite easy. Anit has given an answer. Anit has given the answer as B. Let's see how did he solve this. First and foremost, I need to know if it's given as equilibrium constant. So the reaction is taking place at equilibrium. So if I use the Nernst equation, I will write E naught, E cell is equal to E naught of cell minus 0.0591 by n log k. Okay, log k. Now if the reaction is taking place at equilibrium, E cell becomes equal to 0. E naught cell मुझे calculate करना है, and 0.0591. What is the value of n? Okay, सविता लो लेवल क्वेश्चन, मैन जेई मेंस का क्वेश्चन है तो लो लेवल नहीं होता है. जब आप एग्जामिनेशन में बैठते हो ना तो सारे इजी क्वेश्चन, डिफिकल्ट क्वेश्चन सब कुछ एक ही लेवल पे हो जाते हैं. ओके, इट्स नॉट अ लो लेवल क्वेश्चन, डोंट से दैट. बहुत मुश्किल से लोग क्वेश्चन बनाते हैं, बहुत मुश्किल से लोग क्वालिफाई करते हैं. यू आर लुकिंग एट द क्वेश्चन फ्रॉम अ डिफरेंट सिंगल क्वेश्चन देख रहे हो. पूरे पेपर को जब देने बैठोगे then scoring even 200 becomes challenging. Okay, so log Kc, और Kc की वैल्यू क्या है? Kc की वैल्यू क्या है? 10 times 10 raised to 16, so I'll write 10 raised to 16. 10 times 10 raised to 15, so I'll write it as 10 raised to 16. So this will become E naught cell, which is equal to 0.0591 upon 2 times 16. Minus minus cancel हो जाएगा. You will get a positive answer. Okay, you will get a positive answer. So your answer should be equal to, कितना आंसर आ रहा है? The answer will come as to be, it will not be in millivolts. I think the answer should be B. The answer should come as to be equal to B. So this question tries to tell us that the topic electrochemistry though looks very difficult, विकल्प एग्जैक्ट आंसर लाने की जरूरत नहीं है, हमें 4 ऑप्शन में से एक करेक्ट आंसर बताना है. सो इट्स नॉट नेसेसरी दैट वी नीड टू गेट द राइट आंसर, एग्जैक्ट आंसर. थोड़ा भी क्लोज अप्रोक्सीमेशन भी आप ले सकते हो. Like this question tells us that all questions in JEE Mains do not require the same amount of time. Some questions require less time, some questions require more time. So you have to choose and move ahead. देखिए, अगर आपने difficult question solve किया तो आपको लगेगा कि मैंने बहुत बड़ा काम किया, but examination requires that you solve good, medium and easy difficulty level questions as much as possible. So अगर मान लो कि 30 questions दिए गए हैं, ओके यार मिली वोल्ट्स क्यों नहीं, क्योंकि अरे आप यूनिट्स ले लो ना. ओके, सो let's say there are 30 questions and out of those 30 questions you solve 10 difficult questions and somebody solves 20 easy and 20 easy questions or 20 easy medium difficulty level questions. आपको लगेगा, you will feel कि मैंने बहुत बड़ा काम किया, मैंने 10 डिफिकल्ट सवाल सॉल्व किए. लेकिन एग्जामिनेशन में उस बंदे ने जिसने कि 20 इजी क्वेश्चन सॉल्व किए हैं, ही इज गेटिंग 80 मार्क्स और आपको कितने मिल रहा है? 40 मार्क्स. ओके, examination will recognize that guy as to be more talented than you. So examination hall is not a place for experimentation. वहाँ पे सुपरमैन नहीं बनना है. You have to solve, pick and choose वो सारी चीजें करो जो कि easy हैं. ठीक है? So let's move ahead. Let's take the next question. Okay? Let's take the next question. For the cell zinc changing into zinc 2 plus combined with another cell, another half cell, different half cells and their standard electrode potentials are given below. If E naught zinc 2 plus zinc is minus 0.76, which cathode will give maximum value of E naught per electron transferred? Okay? Okay? Which cathode will give maximum value of E naught per electron transferred? You can see these values are given over here. Try to solve the question. The question is right in front of you. I am combining this cell zinc changing into zinc 2 plus with one of the other half cells, and I need to calculate which cathode is going to give us maximum value of E naught per cell. Okay, Yash has given an answer C. Think carefully. Anybody else? Anybody else? A lot of people have made a mistake in this question. Okay, this question might look easy to some people, but a lot of people have given incorrect answers. Vikalp is saying D, Shanu, Srinivas, B, Anamika says B. Okay, so try and understand this thing very, very carefully. Okay, see, when we use this, do you remember this equation? Delta G is equal to delta G naught minus, delta G is equal to delta G naught plus RT ln Q. I hope you know this equation. This is free energy, the standard free energy change, RT ln Q. Now, if I substitute this with minus NF E and minus NF E naught plus RT ln Q, what are we doing is that if delta G is written as equal to minus NFE, then doesn't it look like E is equal to delta G upon N? E is proportional to delta G upon N. Okay? E is proportional to delta G upon N. Think carefully. E is proportional to delta G upon N. So, whenever we are calculating cell potential or whenever we are calculating E naught, we are actually calculating it per electron. Okay? We are actually calculating per electron. That is the reason in the previous session we had seen that when we calculate the E cell, it does not matter if the number of electrons are equal or the number of electrons are unequal. It does not depend on the number of electrons. So when you are looking at E naught per electron transferred, this statement is nothing but calculate E naught. Okay, this statement is nothing but calculate E naught. A lot of people, what they will do is they will calculate E naught and divide it by electrons. Okay, a lot of people, what they will do is they will calculate E naught and then divide it by the number of electrons. You are not supposed to do that, because when you are dividing it by electrons, you are actually calculating delta G by N square. जबकि आपको calculate करना है delta G by N. So E naught is intensive property, does not depend on the number of electrons which is transferred in a redox reaction. इसको याद रखो. E naught per electron. This is just given to confuse you. This is just given to confuse you. Clear? So, इसको बहुत अच्छे से समझ लीजिए. I will couple 0.76 with 1.4. Okay, I will couple 0.76 with gold. So अगर मैंने gold and zinc का लिया, then what will I get? So let's say gold and zinc, I will get 1.4 plus 0.76. Okay, gold को हम cathode रहने देते हैं. Zinc is made a anode, so zinc will change. This is reduction, so इसको 0.76 कर दिया हमने. Next, E नॉट पर इलेक्ट्रॉन का कोई मीनिंग नहीं है. E नॉट एक्चुअली पर इलेक्ट्रॉन पे ही निकाला जाता है. ओके, E नॉट पर इलेक्ट्रॉन लिख देने का मतलब, फॉर एग्जाम्पल इफ आई से दैट व्हाट इज योर फादर्स नेम हु इज द सन ऑफ योर ग्रैंडफादर, so that does not make any sense. Okay, your father is the son of your grandfather, man, so that is completely redundant statement. So ऐसा ये statement अगर किसी ने दे दिया कि E नॉट पर इलेक्ट्रॉन, इसका मतलब ये नहीं कि आपने E नॉट निकाल के फिर उसको इलेक्ट्रॉन से डिवाइड किया आपने. Don't do that. Okay, now this will come as to be 7 plus 4 11 2.16 volts. Okay, and if I come Ag plus and zinc, I will get 0.8 plus 0.76. If I take Fe3 plus and combine it with zinc, 0.77, 0.76, this will be 1.56, 1.53. Okay, and Fe2 plus zinc, it will be this is obviously going to be very, very small. Okay, so a lot of people, what they will do is they will divide it by the number of electrons transferred, which should not be done. Because whenever you are calculating E naught, you are actually calculating it as delta G by N. Okay, so E naught is not dependent on the number of electrons exchanged. Otherwise I would not have explained this earlier. हमने questions देखा है जहाँ पर कि number of electrons given out or taken in are unequal and given out or taken in are equal. I just have to take the E naught oxidation and add it to E naught reduction. I do not bother about the number of electrons. So even if it is given as E naught per electron, you should not be bothered about that. The right answer to this question would, however, किसका होगा? सबसे ज़्यादा value कहाँ पे आ रही है? Gold. Answer should be C. Okay, so you can see how they can trap you in a question. Okay, how they can trap you in a question. You should not worry about a new word. Understand the basics. This is why understanding the theory part is more important than solving questions. Clear? So remember, E naught is always, or E cell is always delta G by the number of electrons. Chalo, let's move ahead. Let's take this question. Okay? So for the electrochemical cell, you can see the cell, the standard EMF is 2.7 and the concentration of Mg2 plus is changed. Okay, standard EMF is 2.7. When the concentration of Mg2 plus is changed to x molar, the cell potential changes to 2.67. The value of x is. So this is a JEE advanced question. This is a JEE advanced question, but very, very easy because you are just given the concentration change and you are given standard value and the changed value. Clear? Standard value and the changed value. What is the right answer? बताइए क्या आंसर होना चाहिए? This is JEE Advanced 2018 question. So I have taken similar questions. I have taken JEE 2019 mains and JEE Advanced 2018 questions and JEE Advanced 2019 questions. The reason is to tell you that you fear electrochemistry so much, but the questions that you are getting are not very difficult. Okay, yes, it's an easy peasy question. Bataiye, what will be the answer? How should you solve this question? Very easy question. You can see that this is oxidation half cell, this is reduction half cell. Okay, when it is oxidation half cell, reduction half cell, how do we solve the question? I just know that N is equal to 2. I will use this equation. E cell is equal to E naught cell minus 2.303 RT by F NF log Q. Okay, log Q. E cell is given as how much? 2.67. E naught cell is 2.7 minus 2.303 times RT by 2F log. If I write the reaction would be written like this: Mg plus Cu2 plus changes to Mg2 plus Cu. Okay, you'll get this. Now if you try to solve this, what is the answer that you would be getting? You're getting the answer as root 10 or 10. I don't know. 10 is the answer. Let's see. So this will be written as Mg2 plus ion concentration by Cu2 plus ion concentration. You will take Mg2 plus ion concentration as to be equal to X and Cu2 plus ion concentration is equal to 1. Solve this equation, you will get the answer. So this is a subjective this question. See, in 2018 they had introduced a new feature that the answers to integer type question could also have decimal places, and that's the reason your answer could go beyond a 9 as well. So whatever be the answer, मुझे answer नहीं मालूम है. If answer is coming as equal to 10, so then we can accept the answer as equal to 10. Okay, so is everybody getting 10? Is everybody getting 10? A lot of people have answered that they are getting 10. इसको यहाँ पे सारी चीज़ें आपको दे दी गई हैं कि F by R, because when you will subtract this, you will get it as minus 0.03, and minus 0.03 times 2 times F by R 1 by T you will get. So approximately 10. Okay, cool. So if you are getting the answer as approximately 10, the answer should be like, let's written at 10. Like, do a proper approximation, getting us 10. चलो ठीक है, 10 को मान लेते हैं. So not solving this anymore. यहाँ के बाद सारी चीज़ें easy है. जिसको आप x लेना, इसको 1 लेना. Okay, चलो. Next question is this. Okay, next question is this. Consider an electrochemical cell where A is changing into AN plus and B is changing into B. The value of delta H naught of the cell reaction is twice that of delta G naught. Okay, delta H naught is given as twice that of delta G naught. If the EMF of the cell is 0, the delta S naught is equal to what? If the EMF of the cell is 0, the delta S naught will be equal to what? Per mole of B, which is formed at 300 Kelvin. How do we solve this question? Okay, so I'm gonna explain. It's a very simple and a straightforward question. First and foremost, I'm just gonna give you the idea. A changes to A N plus. That means it gives out N electrons. Okay, A changes to A n plus, that means gives out n electrons, and B n plus 2n plus takes up to n electrons to change to B, isn't it? So if I multiply this with 2, I will write the equation as 2A plus B 2n plus, that changes to an plus 2b, sorry, 2an plus b. Okay, so if I want to write the expression for Q, it will be an plus whole square by b 2n plus. an plus की concentration क्या दी गई है? 2. an plus concentration is given as 2, so 2 to the power 2 upon 1, that turns out to be 4. Our value of Q turns out to be equal to 4. Okay, minus तो नहीं होगा, plus होना चाहिए. Okay, it is equal to 4. Now I know this equation, delta G naught is equal to delta H naught minus T delta S naught. भी लिखते हैं. Now delta G naught को ये लिखा जा सकता, delta H naught को क्या लिख सकते हैं? 2 delta G naught, because it is already given that delta H is twice of delta G naught, minus T delta S naught. So this will become minus delta G naught is equal to minus T delta S naught. Okay. Also, if I'm doing the reaction at equilibrium, then can I say that delta G naught, delta G is equal to delta G naught plus RT ln K, or delta G naught is equal to minus RT ln K? I can write this. Delta G naught can be written as minus RT ln K, तो हम यहाँ पे minus RT ln K लिख देते हैं, RT ln K, which is minus T delta S naught. This T and T gets cancelled out. R value is 8.3 and K value आपने पहले कैलकुलेट कर लिया है 4, and ln K, so ln 2 is 0.7, so ln 4 will be equal to 8.3 times 2 times 0.7. Okay, R ln 4 will be equal to 8.3 times 2 times 0.7. That should be your answer. That means 8.3 times 1.4 should be your answer. So 11 point something के आसपास आंसर आ जाएगा. Okay, you will get the answer as equal to 11 point something. Okay, Nick Rathore, the answer is correct. Your work might be incorrect, but the answer is correct over here. Okay. The answer should be 11.62. Yep, the answer is 11.62, and that's the exactly correct answer. You can solve it from the E-cell method as well, but that's not necessary. Okay. So this delta S naught का value ये हो रहा है. This is nothing but delta S naught's value. Clear? So the next question is a homework for you guys. You can see that the cell is cadmium, changes to cadmium hydroxide, and NaOH concentration is 0.01 molar. I'm just highlighting this. This is 0.01 molar, and this is cadmium hydroxide, H2 1 bar. CD2 plus changing into CD is minus 0.39. You have to calculate solubility product of cadmium hydroxide. So you have to calculate solubility product of cadmium hydroxide. This is the homework question for you guys. Try to solve this question. कितना आंसर आता है? Please do write in the comment section. Please do write in the comment section and please let me know. Okay? Next question class में इसको हम discuss कर लेंगे. Also, it is information to everybody that the Vedantu 1 year long term programs enrollments are already on. Please do appear for VSET so as to avail handsome scholarships which you can avail, which you can use to join the 1 year long term JEE program. Okay, so and same, there is no daily schedule. There is a daily schedule. Okay, there's a daily schedule. I come online on YouTube on Monday, Wednesday and Friday. Pahul sir comes on Tuesdays and Thursdays. So this is for the 1 year long term program. If you want to join the 1 year long term program for JEE 2020, please do log on to the Vedantu website, and there the link is also provided in the course description and the comment section. Okay, please do let your friends know about this as well. And the next session is with Pulkit sir on tangents and normal. Please do stay for that. And there's Sourav Goswami taking leave from you guys, and will join in the next session with another interesting topic, that is concentration cells. Bye bye guys, and have a lovely time.